Hi, my name is Dave Growing, and I am here to show you the meter calibration calculator applet. This movie is created in portrait mode only, yet please keep in mind that the program was written for both portrait and landscape mode use. In other words, the orientation can be changed at will by simply rotating your device at any point while using it, and may actually look better on your device in one orientation rather than the other. I have worked in the ready-mix concrete plant automation industry for well over 2 decades now. For this one reason alone, any conversion factors related to weight per gallon will be 8.33 pounds per gallon, based upon ready-mix concrete industry standards. After a couple of splash screens are displayed while the database is being loaded up, we land at the Meters Picker menu. This menu displays the 13 different physical meter sizes which the PFT-1E and PFT-4E meter boards allow for. I will swipe the screen to scroll down the list to show you all of those possibilities, of which there are actually 13 of them. To start with, I'm going to select the Turbo 3-inch meter from the meters picker. By doing so, we are automatically taken into the calibration wizard. From the calibration wizard, the meter that we have chosen to use is displayed on the top of the screen. At this point, there are 3 check boxes, all of which are unselected by default. We could calibrate in either ounces or gallons, while in the imperial units mode, or we could calibrate in milliliters or liters while in the metric mode. For our first demonstration, we will use imperial units and choose gallons. Upon choosing the gallons checkbox, 1 gallon per pulse displays on the screen by default. 1 gallon per pulse happens to be a typical configuration used in the concrete industry, which I will choose in this demonstration. At this point, since I do want to calibrate in gallons and I do want the meter to output 1 pulse per gallon, I'm going to depress the calculate button, and after doing so, we are taken into the calibration calculator menu. From the top of the calibrate calculator menu, we now see that we have chosen the 3-inch turbo meter, which has a typical starting scale factor of 0.0403 for our 1 gallon per pulse scenario, which is displayed on the second line. The initial scale factor of the board is shown on the second line, which is the same as the typical starting scale factor, yet quite possibly not reality. For our purposes, I'm going to enter in a different scale factor and change the 0.0403 to 0.0411. In our first test, we're going to attempt to call for 300 gallons of liquid. And the counter from our control panel actually displays 302. So that is the value that we will add into the quantity called for. 302. Our overall calibration goal in this test is to achieve plus or minus 1% accuracy. Now we have two different means of measuring the liquid. Volumetrically from a graduated cylinder or by weight. For our first test, we're going to choose weight. And after weighing our results, we have determined that to be 2,579 pounds. So 2,579. And then I will go ahead and depress the calculate button. We now see that we have a 2.52% error, which happens to be positive. Otherwise, we would see a negative symbol in front of the error percentage. The new calculated scale factor for this meter is 0.0421. And we will, at this point, want to calibrate to that new setting after physically changing the scale factor on the meter. And once we have done so, I am simply going to touch the scale factor area on the calculator, which will change the new scale factor to 0.0421. We're going to run another test and attempt to once again call for 300 gallons, yet this time we receive 301 on our counter. So we change our present 302 to 301. And after weighing the results of our second test, we end up with 2,502 pounds. So I will enter that in as 2,502. And then depress calculate. This time we see that we are within minus 0.21% error, which is well within our calibration goal of plus or minus 1%. Now we will just run another test without changing the scale factor to see that we have repeatability. In our third test here, we attempt to call for 300 gallons as always in the past two tests, and just happen to receive 300 gallons on our counter this time. So I'm going to change our 301 to 300, and we have weighed our results, and we end up with 2,513 pounds. So 2,513, and I'll hit calculate, and this test once again provides us with accuracy to within plus or minus 1%. of our initial design goal, uh, which is 0.56 on this round, actually minus 0.21 previously. So we will conclude our testing for this particular calibration scenario. In our next calibration illustration, we will use the volumetric capabilities of the application, which utilizes graduated cylinders. We will choose a RCDL 5/8 inch meter to calibrate for 4 ounces per pulse to within plus or minus 3% accuracy. We go back to the meters picker and choose the RCDL 25 5/8 inch meter. The meters picker is the very first symbol at the top of your device, and the Recordo 25 happens to be the very first selection that we had in our list, and we were wanting to calibrate to ounces, and more specifically we were looking to calibrate to 4 ounces per pulse. So I'll erase my 1 and add in 4 and depress my calculate button. And so in this test, we're going to assume that this is a new installation of the meter, and we're going to keep the suggested starting scale factor of 0.613, which we have already set to. We'll call for 100 ounces and actually get 101 on our manual counter. So I'll enter in 101. And we actually see that from our graduated cylinder that we have delivered 105. So here in the ounces delivered, I'll enter in 105 and depress the calculate button. This gives us 3.96% error, which is outside of our goal limits of plus or minus 3%. So now we're going to physically change our scale factor on our board to 0.1677. We're going to touch the scale factor on our device, which is going to then change our existing 0.1613 to 0.1677 on our device, and proceed forward just as we have with previous examples while retesting for an acceptable result. I believe that you will find that the steps required from this point forward in regards to calibrating and metric is as straightforward as was with my previous imperial examples. If you like this free Android program, which is my very first, please help by providing me with a nice review. If you have any questions or issues with this program, please email me at db@droidbase.net, and I will do my best to resolve them. In the meanwhile, I hope this video was helpful, and thank you all.